All right. Welcome, everyone. Today we're going to be learning about Docker. So we're going to be covering a couple of topics, but before we even start going into our overview, let's think about why we would want to learn something like Docker, right? Well, Docker has become a very popular framework, and it's very good for keeping our applications lightweight. Now, what do I mean by that? Before yesterday, when we covered deployment, we were talking about the pricing that's happening within AWS and why it's happening. And I let everyone know that most of the time you have to end up paying at the end of the month because your Postgres instance is always running in the background, right? You have Postgres installed and it's always running as a background service within your virtual machine that you're deploying on the AWS framework. But when you're utilizing Docker, you're actually minimizing the amount of space that database will utilize, or the amount of space that any one of your project frameworks might utilize while being deployed. And it does that by utilizing a container rather than utilizing the entire framework itself to be able to run correctly. It gets a little confusing, and we'll go a little bit more in depth once we get into the lecture, but that's the main powerhouse behind Docker. So let's go into the overview. Today, we're going to go ahead and cover what is Docker. We're going to cover what's the difference between a Docker file and a Docker image, and what's the difference between an image and a container. Once we talk about that and we have that clarified, we'll go ahead and talk into what's the difference between containers and virtual machines. Finally, we'll go into creating our container, which will be running Postgres in the background. And then we'll be entering that Postgres container instance through our terminal. But it's going to be different than the Postgres that's living in our actual machine. All right, at this point, does anyone have any questions over what will be taught today? Keep in mind, none of this information will be evaluated. This is all just extra material for you guys to utilize and to have in your tool belt. Okay, great. So let's go into it. What is Docker? All right, so here on the right-hand side, you can see that I'm already in Docker Hub. I'm already inside of my account, so it doesn't give me like the nice, pretty summary of Docker. But what Docker actually does, or the capability that Docker brings to your site, is that it runs your instances through something called containers. So essentially, let's go ahead and draw this out, right? This is my machine. And currently in my machine, I have a bunch of installments, right? So I have, let's say I have Python, I have JavaScript. At some point within our application, oh, and actually not JavaScript, I apologize, this should be Node. At some point within our application, we ended up having Django running as well. Or maybe we have a virtual environment that's running Django, but now we're keeping track of that virtual environment. Right. Then after that, we also have some sort of Vite development system. So there's our Vite process as well. And then on top of all of that, we also had our Postgres instance running. So at minimum, because there's a lot of other background services that are running when we're running this our full stack application with Django and React, these are the very minimum things that are running at all times within our machine to make sure that we can communicate within different files, to make sure that we're able to compile different files, and to make sure that we're actually able to interact with our database. So now that's great. And it's all running within my machine. Now, what does that mean to me? Well, when it comes to efficiency or space, whenever I utilize Python, I'm not just utilizing the specific portion of Python that I need. I'm entering the entire Python library. Same thing with Node, right? If I want to utilize something from Node, I'm not just entering that specific instance or that specific module from Node that I need. I'm grabbing all of Node and installing it. And I'm sure we've all seen it, right? When we installed Node for the first time, that one was probably our largest installment, right? We just saw packages coming in one after another. Virtual environments, same thing, right? When we create a virtual environment, we can see that a a ridiculous amount of files are created. And every time you install something into that virtual environment, even more files are created to keep efficiency and to make sure that it can generate the requirements TXT or reference the prior installments whenever you're working with a project within that virtual environment. Our Vite server also has a considerable amount of node modules that we see once we run npm install. And the point is that all of these different frameworks are running with a lot of things that we really don't need, right? There's a lot of times where we're not messing around, I apologize. There was a lot of times when we were exploring a specific framework and we saw a file or some sort of configuration and we had no idea what it did, right? We could definitely do some research, figure out what it does, figure out how to alter it. But in all reality, we likely won't even need to alter that file or need to have access to that file. Well, that's what containers kind of come and fix, right? So let's take Postgres, for example. Rather than running my entire Postgres instance and occupying my entire machine, what I can do is I can tell Docker to run all instances within my machine. So now the only thing that my machine is actually running and keeping track of is going to be Docker itself. Right? It's not keeping track of anything else of Python or of Node or anything. It's just running Docker. Well, within Docker, I can now run a small Postgres instance. And I say small, but it can be as big or as small as I want it. And I can tell this Postgres instance exactly what size I need it to be. I can tell it what users it needs to have, if any, and I can enter this instance to change information through Docker, right? And by doing this, I'm essentially making sure that Docker is only running the necessary files or installing the necessary information to be able to run this Postgres instance and nothing else, nothing extra. Everything else that's extra, if Docker ends up needing it, that's outside of the default things, the very minimum requirements to be able to run Postgres, your image or when you go to build your image will actually fail. Or if your image does not fail, when you run your container will have some unexpected behavior. But let's take a pause here for a second and let's just think about this, right? When we haven't worked in group projects yet, so we haven't seen this just yet. But I'm sure that whenever we were working inside of our teams or we were working within our pair programs, when we were doing pair programming, eventually we had run into an issue where we wanted to pass off a project from one another, right? Maybe specifically in Django. Maybe you get stuck and you say, hey, can you pick up and maybe I could drive, or maybe I can navigate so that I can see this from a different perspective. So you go to attempt to share that project with somebody else, right? Well, when I share that project with someone else, let's say I'm on Mac and I'm sharing it with Chad, for example, and then Chad ends up saying that he has WSL. When I pass it over to him, maybe we don't have the same exact requirements to be able to run the project. So now we're running into some unexpected errors, right, between the two machines. Maybe our requirements TXT doesn't have the correct versions for one another. And there's just a lot of extra loopholes that we have to jump to before we can even get the project running on a separate machine. Well, if I'm running everything through Docker, and Docker is in charge of making sure that everything's running the same, when it doesn't matter where the project is living, it doesn't matter how we're sharing it to one another, because Docker is essentially going to take that one Docker file and it's going to read it exactly the same way that I read it on my machine is the same way that it's going to read it on any other machine. So it makes the ability to share your project or to share information from one developer to another extremely easy. And it's also going to simplify everything once we go into deployment, because Docker will take care of all of it. We won't necessarily have to mess with GitHub at all. We'll just be able to clone down our Docker repository, and our Docker repository will already be holding our image for all of our containers that will be ran. And then once we run those once we run that image to run our container will essentially just do a direct reflection of what was running on my local machine. Right. So yesterday, we also saw that when we were running before yesterday, we also saw that when we were running React development server versus running Nginx to host our static files, there was a considerable difference between the two projects, right? Especially when it comes to design. Well, now when you put it within Docker, you could have Nginx rendering your React application from the very beginning. That way you can see what it's going to look like once it's actually being rendered on the web. And this is essentially what the Docker capabilities and limitations have to offer, and what it fixes, and what the tools that it provides for you. Does anyone have any questions regarding what is Docker?
What's an image?
Oh, that is an excellent question. We're actually going to be covering files, images, and containers here shortly. So I will address that question here in a bit. Okay, can anyone tell me maybe just one pro that comes from utilizing Docker when we're talking about sharing projects between one developer to another?
It eliminates the issue of working in one environment but not in another.
Awesome. Thank you so much. All right, so let's go into our next subject. And in our next subject, we're actually going to talk about a file versus an image versus a container. All right. So once you go into creating a Docker file, so currently here in this directory, I have a markdown file and I have a Docker file. When you go to create a Docker file, the command is quite literally Docker file. And the reason why I highlight that is because I always thought that it had to be something like .docker or something along those lines, but it does not. You just write Docker file, and that creates the actual Docker file that Docker will be able to read and create an image from. So our file is going to be essentially just like a Python script, right? We're going to tell Docker what exactly it is that we want this one file to create. And a file is utilized to create an image. All right, so let's see if I can break this down a little bit. Okay, so here we can see that a file is going to turn into an image, and then an image will turn into a container. So a file is essentially a script with directions to have Docker build an image. Okay, so that's all that file does, right? It's just the script, and it will build an image. Now, what is an image? Well, once we have a Docker file run successfully and build an image is basically going to be an instance of a set of directions for creating a Docker container, and will live within Docker itself. So we have our file. Our file is created. It has all of these directions. Hey, this is what I want you to do to be able to run a successful imaging container. Once we run that through Docker and tell it, I want you to build an image off of this file, Docker is going to read those directions, say, okay, all of these directions are good. They're solid. I can actually do this. Instead of just immediately running into creating a container, it's going to take essentially a screenshot of all of your, or a copy of all of your directions and save them within something called an image. And that image is literally just going to hold on to your directions and have them living within Docker. So that when you go ahead and maybe you want to change something in the Docker file, you can change something in the Docker file without changing the image itself. So you can keep different versions of the same directions, just saving them inside of separate images. And then finally, that image, once you run it, you can create a container. And a container is actually an instance of a running instance, I apologize. A running instance of those directions being executed. All right, so there's the three differences. We have our file, which is just a script, an image, which is a copy of that script or those set of directions, just living virtually within Docker rather than living in my local machine. And then a container, which is the actual execution of those directions being built out and then continuously running until I tell Docker to no longer run that instance. Those are the three different elements that go into being able to actually run a Docker container. And we'll go into building each one of them here shortly. Does anyone have any questions over what is a file, what is an image, and what is a container? And actually, we'll save those questions until after we build our image, because I feel like it's going to be a lot more clear once we actually go ahead and start seeing some code and breaking it down. And then we'll actually address containers versus, we already addressed containers versus virtual machines, actually. So let's go into actually doing some code. So now we have all this information. I know how this works. I know that this Docker file is going to create a Docker image. And if you look at our main README inside of our curriculum, inside of the Docker module, it's going to run to you. It's going to tell you how to be able to install Docker into your machine. It's going to tell you that you'll have to install the Docker desktop application. And then after that, you'll have Docker available to you in the command line. It shouldn't take very long. It's a pretty friendly install, and it's very flexible for different machines. But essentially, once you have that installed, you'll be able to run Docker within your machine. And once you run Docker, you're going to get a series of commands that you can utilize. Now, within the same module, we also have a cheat sheets directory that holds a couple of different markdown files for how to utilize each one of these commands. But today we're going to stick to the basic commands that we'll need. So the first thing that I want to check is if I have any images running. So if I run Docker PS, any containers running, that's going to show me all of my containers. And here we can see it shows me that any container that's running is going to have a container ID. It's going to have the name of the image that it was built from, any commands that are being executed from said container, when it was created, its status, what ports it's running on, and the name of said container. Well, now I currently don't have any. Well, what about images? If I want to check my images, I can run Docker images -ls, or I think it's just Docker images ls. There you go. No dash. So there it tells me, hey, is there a repository? If there's a repository attached to it, it will tell me what it is. It's going to have a tag that's attached to it, and that's optional. I could give it a tag or I can not give it a tag, but it will have an image ID that I can reference this image by. It will tell me when it was created, and it will tell me the size of that image. Well, that's great. I know that I don't have any images and I don't have any containers running. Everything's empty within Docker. So now let's go ahead and actually talk about how we would build a Postgres image or a Docker file that would run Postgres. Well, this is the other beauty that comes with Docker. Whenever you want to create something within Docker, you don't necessarily have to start from scratch, right? For us, we started from scratch when we installed everything into our machine. But here, you can go into the Explore tab. The Explore tab is going to pull up all these things. I can say that all I want to see is images. And I can go, I'll stay with suggested. Let's see what else we can do here. Let's say that I want to look up Postgres. And all I care about are images regarding Postgres. So here's going to tell me there's PostgreSQL. And then you want to take a look at the images. You don't want necessarily something that hasn't been confirmed or that isn't like official, right? So here we can see that this is the official image. Look for something that's at least verified publish or a verified publisher. Don't use anything that's kind of weird. I wouldn't go anything below verified publisher whenever you're utilizing these images, unless it's something necessary for the project. Right, but here we have the official image. It was updated 4 days ago, so this is great. And it tells me the command on how I could utilize this image, right? I can just say Docker pull Postgres. If I run that into Docker, that's just going to pull the entire image automatically. That's not necessarily what I want. We could do it that way just to make things simple, but we want to make sure that we get the experience out of building this Docker file, being able to see what's going on and how it works. Oh, yes, I got a question. Go ahead, please.
I guess at what point are we implementing this Docker file in our project? Or I guess in general, like where are we in our project that we're starting to create the Docker file?
Yeah, definitely. So your Docker file and your project itself won't live together. Like they won't be attached, if that makes sense. Meaning that Django won't need some sort of reference to Docker in order to be able to run properly. And same thing with React and Postgres. What's actually going to happen is we're going to tell Docker to read our files. We're going to tell Docker, hey, I want you to copy this Django project into this one image. And then that way you have a direct copy of it. And then once you run this image and create a container, I want you to render these files that are coming from the Django project that you copied. And then same thing with React. We're essentially just copying and pasting what's living within VS Code and our local machine into a container, into a Docker container. Does that make sense, Claire?
Yes. I guess what I'm trying to say is, are we doing this after we just, created the basics for our project? Are we doing this like after we finished our project and we're about to launch?
Got it. Okay. So you're saying like in timeline wise, when is it that we would want to connect Docker? That's definitely more user preference, right? So for example, if I was a front-end developer, I would probably want to run my project within Docker just so I could see what it would look like once it's deployed, right? And I'm not creating fake CSS that's not actually working properly. Now, if I was a backend developer that's working within Django, maybe I want to do things locally just out of preference for the majority of the time. And then once I have it working locally, I can move it into Docker and make sure that it's able to talk to the other container that's holding my database properly. But that all kind of comes into a user's preference. But for sure, you would want to have everything Dockerized and living within Docker before deployment. So at the final stage of your product, right before deployment, you would want everything Dockerized and within Docker so that you can just deploy the Docker containers themselves rather than your entire project individually. Does that answer your question, Clarice?
Yeah.
Okay, awesome. All right. So now we're back here into Postgres. Oh, so for Flow, maybe build backend, make Docker, and then build the front end. So whenever you work on something, whenever I create a project, and that's a good question, Brian. When I create a project, the first thing I do is I imagine what the front end would look like. I draw out the front end, I draw out what each component would render. And then from there, I can kind of imagine what I need my JSON response from my backend to look like, right? So then I map out what my response would look like. And once I map out what my responses would look like, then I could think, this is what my models need to look like in order to build these JSON responses, right? So then I could build my backend by thinking of that. And once I build my backend, well, then I can also think, if this is what my models are going to look like, then this is what my database relationships are going to look like. So I think of it kind of like a sandwich, right? You go front end, and then database relationships, backend. And then whenever I go into building it, I always start off with my backend and database and then do my front end last. But that's just my preference. Does that answer your question, Brian?
Yeah, that sounds so like plan front end and then build and then plan your back end and database based on that, and then start building the back end and database and then build the front end. Is that, yeah, that makes a lot of sense. Thank you.
All right. Now that we're back into our Docker conversation, as I said, we're currently within our PostgreSQL image, but let's say that I wanted to run the latest one, right? The newest one. Well, here we can see all of the different versions of Docker that are currently running. We have 14, 15, we have all of these different ones, and they're all just essentially a bit different. They're not actually drastically different. They may meet different needs. So you could look up which one of these images would fit your project the best. I usually just click on latest. And then here we can see in latest that it's actually just going to show all these different information. Well, all of these commands are running whenever you grab this Docker image, right? And we can see that it's actually setting up all of Docker, where it's setting up paths already within Docker, right? Where we can see that it's telling it, hey, this is where this is going to live. This is the information that you're going to use. This is how everything's going to be encrypted. It's specifically telling my Docker instance how it's going to create Postgres. And at the very end, we can see that it even tells me it's going to be running on port 5432, and the command to enter this in this specific instance will be Postgres. Okay, that's great. I don't necessarily need to fully understand everything that's going on in here, because if that was a necessity, then what's the whole point of using Docker, right? As you get further into your software engineer career, there may come a time when all of this information kind of becomes vital and you need to know exactly what's going on here, because you may have to change one specific line in this entire file. But currently at the stage that we are at, we don't really need to fully understand everything. We can utilize the magic of Docker to really maximize its potential. So how do I do that? How do I grab this information? Let's go back to Postgres here. And here in Postgres, we can see that it has a quick reference to. So we have our supported tags for Docker file links. Now, for me, what that means is that within my Docker file, I can tell it that I wanted to grab from Postgres, and that means that it will go into Docker Hub, find Postgres, and then say, what is it that you want from Postgres? Well, I want you to grab the latest version from Postgres. So now it's going to grab the latest version from Postgres, which is where we're currently at. And it's essentially going to run or execute this entire file whenever we go to create an image. So now instead of writing this all by myself, I was able to utilize Docker to pretty much do all of the heavy lifting for me. Now all I need to do is specify environment variables, right? Well, could I handle environmental variables? Let's say that Postgres is going to have a user, and I want that user to be, I guess, Francisco. And this is also going to have a password. It's not a necessity, but let's say I want it to have a password. And I'm just going to make this FR. So there's my two environmental variables. I gave it a user and a password that's specifically designed to reference myself. Now, what if I wanted to expose a specific port? Well, currently, if I run PSQL, we can see that it is attempting to access 5432, right? Now, this is my local machine's 5432. This is not my Docker instance, 5432. Remember that Docker is running within itself, right? It's a machine that's running inside of your local machine. So they're two completely different ones. They're not, they have their own ports. You can bridge them together to be able to access, but they all have their own ports. So in order to be able to bridge them together to a port on my local machine, I need to expose the port 5432. But this 5432, again, is not coming from my local machine. This 5432 is coming from here. All right, we know that Postgres is going to be running within port 5432 inside of Docker, not my local machine. Okay. So then finally, we'll set up a couple of other environmental variables. Let's say I want there to be a Postgres database that I want to utilize. And for this example, let's say that we're just going to create a to-do list. So we'll go with to-do DB, all right? And then finally, the last thing that I wanted to tell it is how it's going to encode all of my data that is being passed into Postgres, because we don't want this stuff to just be accessible to everyone without any actual encryption. So I'm going to tell it how that's going to work. So here we have encoding UTF-8. I believe some of this specifies what kind of language it is that it's going to be utilizing. I'm not going to spend too much time speaking about what exactly it is that this command does. Please feel free to look it up. I'm sure you can find it pretty easily. It shouldn't be too complicated to break down. All right. And then finally, the last thing that I wanted to do is I want to run the command. And there it tells me this is the part that's executable. Well, I want to run Postgres, because this is what's actually going to run this instance. All right. Okay. And actually, if you look inside of our curriculum, there's a pretty good explanation for it. Looks like encoding UTF-8 specifies the character encoding used for the database. The -lc collate sets the collation order for the database. And then the C type sets the character classification for the database. And checksums enables the data checksums for the database. That may be a little too in-depth. I don't think we ever talked about those different capabilities within Postgres. But know that that's what this line is specifically doing. Okay. So now I have all this information running. And if we go back to our drawing, we can see that I now have a Docker file. But what I want to eventually do is get to this Docker container. So what's the next step after having my Docker file created?
Create an image.
I want to create an image. Awesome. Perfect. So now before we go into creating an image, does anyone have any questions over this Docker file and how we went about creating it? All right. If there are no questions, can someone tell me exactly what this line 1 on this Docker file is doing?
I think it's updated to the latest version of Postgres. Is that what it's doing?
Yeah, so it's actually looking into Docker Hub, finding Postgres. Now that it finds Postgres inside of Docker Hub, I'm telling it to grab the latest version that is linked down here. Awesome. So we're able to build our Docker file, but now let's make sure that this Docker file is able to create an image. How can I do that? Well, I'm going to build an image from this file. So I'm going to run Docker build this. I'm going to pass in a flag named -t, and that is to add a tag. And actually, before we even do that, let's just go ahead and run Docker build. And it's going to utilize dot notation to find the location of this Docker file. So currently it's all living within this directory. So I'm just going to run Docker build period. Okay, so it tells me that something failed. So building, failed to solve, failed to read Docker file, open var Docker. Oh, CD into one. There you go. It couldn't find my Docker file. Okay, so there you go. Now it's building. I'm within the correct directory. We can see that it's reading all of Docker, right? So this is all coming from the latest. Oh no, it went away. It was all coming from Docker/latest. We can still see, I mean, from Postgres :latest, we can still see it here being referenced. And down below, it's going to start kind of altering it to meet my needs. Right, and then it tells me there are some vulnerabilities, and it tells me that I can view those vulnerabilities if I would like to. But currently right now, what exactly just happened? What's going on? What does all this mean? Well, all this is saying is it went through each individual line that I provided for it. It grabbed that entire Docker instance that's living on GitHub that came from Docker Hub, and it essentially created the ability to run a Postgres container. Well, let me check out my containers real quick. If I run Docker PS, I still don't have any containers. And this might be helpful to have up here. Right, we still don't have any containers. If I run Docker images ls, it doesn't seem like I have any images. Interesting. I wonder why that is. It didn't fail. All right. Not sure why it's not populating. So it seems like it didn't build properly. So I'm going to go ahead and attempt to build one more time. This time I'm going to give it a tag name so that I can reference it. I'm going to name it my Postgres container. Okay, so it seems like that worked. But it's not showing up. Interesting. May have to do a little bit of on-the-spot debugging. I apologize, everyone.
It's not showing, you're creating the image and it's not showing it that it's created. Is that what's happening?
Yeah, that's exactly, yes, that's exactly what's happening. Let me see. So it's not showing me the image. And I'm wondering why. Not the image. I wonder if this would work. I'm just gonna make sure that this would fail. So it doesn't fail. All right, so it's not showing me the image itself, for some reason. I may need to do a little bit of debugging and get back to the class as to why it's not showing it. But it seems like it's working correctly and that the Docker file is actually being compiled and creating an instance. Unfortunately, it's just not giving me the ability to see it. Huh. But it's living in there. And when you have a second, those environmental variables are creating a new database, right? We can use this syntax to reference a database we've already built. Also, will this database exist in our local Postgres or only inside Docker? Yeah, no problem at all. All right, so to answer those questions real quick, Kate, the first one is the environmental variables. Yes, these environmental variables are creating a new database. In this case, it's creating a to-do database. It's also creating a new user and a new password. You cannot use this syntax to reference a database that's living within your local machine, because this database that you're creating is living within a Dockerized container inside of Docker, not inside of your local machine. So they're not connected to one another. And I think that covered your third question as well. Okay, fantastic. All right, of course. So now that we have that information here, and we know that this is being created, it's not showing it for some reason, which I will have to get back to everyone on that. But this is working correctly. We were able to compile our database and we were able to give it a tag name. So currently, what we have right now, we had a file and now we have an image. We created this file to turn into an image by running docker build -t. That's giving it a tag name. We're going to say my Postgres container. And we told it where to find the container. So path to Docker file. So that's what's happening there. So we pass that information over, and that is what's able to create a Docker image. Well, now that we have a Docker image, I want to actually create a container. Well, how could I do that? Well, if I run Docker PS, oh, excuse me, we can see that Docker PS doesn't have any containers running. Well, I want to tell Docker to build a container from my Postgres container that I just built. So how can I do that? Well, what I can do is I can say Docker run, and let's just run my Postgres container. And then after that, we'll go into each individual flag. Okay, so now it's running my Postgres container. But we can see that although this container is running, what's going on to my terminal? What does this look like?
A server.
Yeah, it's essentially running a server, right? It's saying, hey, this container is now running. It is officially running. It was able to create a database, but the server is occupying my entire terminal. And it's not running as a background service within Docker the way I want it to. Well, as we know, we have daemon mode to be able to run something within background service. So now let's go ahead and do that. Let's run Docker run -e, and let's specify that what we want to run. And actually, excuse me, let me go ahead and run Docker PS. Okay, again, my container was stopped, and because it was stopped, it was deleted. So now I can say Docker run -d, which stands for daemon mode. And what I wanted to do is I wanted to run my Postgres container. Okay, now all I get is this encrypted code, right? It's telling me, hey, what is this encrypted code? Well, this is actually the container ID. If you ever want to reference a container through the container ID, you don't need to utilize the entire string. You just need to utilize enough to make it unique. And then it will find the correct path and autofill the rest of it. Okay, so now if I run Docker PS, now we can see that we have the ID of this container, the image that this container was created from. So here we can see that it's referencing the image that we wanted, which is my Postgres container, the command that was utilized, when was it created, its status, the port that is currently exposed, and that's it. It doesn't give me any names, right? Well, actually it does. So here's the name section. And instead of giving it a name that I provided myself, I named it Eager McLaren, which is just something that Docker came up with on their own. Okay, well now what if I wanted to stop this instance? I can run Docker stop, and I could either reference the name or the ID. So it stops it, and now if I run Docker PS, it shows me that there is no longer a container that's running with this information. And actually, I think that the container does still live. It's just hiding. Let's see. I wonder how I can view any containers, all containers that are currently living. There it is. So Docker PS-A. Okay, so by running -A, it's showing me all of the containers that currently exist. Right, so here we see that we have a Django container that was probably from last cohort, and we have the 2 Postgres containers that we just currently ran. They still exist, but they just they have just been stopped, right? So now if I wanted to remove them, or if I wanted to clean it up, I can run Docker container prune. I will run yes, and that's going to delete all of my containers. And if I run Docker PS-A now, we can see that there are effectively no containers living within my Dockerized machine. Okay, great. So let's continue moving forward. What if I didn't want to remove that container myself manually? What if I wanted that container to be removed automatically as soon as it was stopped? Well, I can run something like Docker run -d --rm. And let's just knock out a name as well. Let's say I want to provide a name. So let's say this is, I'm just going to name it Postgres for simplicity's sake. And then I need to specify what image it's going to use. So I'm going to use my Docker container. Oh, my container. That makes sense.
Hey, Francisco, why would you want to remove this?
Yeah, so we just saw that we manually had to remove it, right? And we had to clean it up. Well, all of that is occupying space within Docker. If I didn't want to, or if I knew that this isn't something permanent that I wanted to keep a track or record of, I can pass in the --rm flag so that as soon as I stop it, it gets deleted, right? Maybe I'm in the process of refining exactly what I want this Docker image to look like. Well, by passing the --rm flag, I can delete my try to have something permanent automatically instead of having to go through the extra step of removing it manually. Does that answer your question, Robert?
I guess I was a little confused, like we created the Docker container and then I guess it served its purpose and then we're getting rid of it type of thing. Or...
Oh, yes. So currently I'm just removing the Docker container so I can show you guys each individual flag and what each individual flag is doing. It's for demonstration.
Okay. Gotcha.
Awesome. Okay, so now when I run this command, it was able to run this Docker container in daemon mode, and it now has a name. The name is Postgres. If I run Docker PS, we can see that the name is Postgres. It gives me an ID, tells me what container it built it of, and all of the other things that we've already talked about. Well, now when I run Docker stop Postgres, it's gonna stop Postgres. And if I run docker ps-a, we're gonna see that it automatically removed it. I didn't have to remove it manually. Okay, so finally, the last thing that we're gonna cover regarding this Postgres instance, right, or this Postgres container, is how do I actually enter this Postgres container? Like, it's great that it exists and that I'm able to build an image, but I can't manipulate it as of right now, and I'm not doing anything to it. So how do I actually talk to this one Docker instance from my local machine, right? Because at this point, I want to enter this Postgres database from my local machine. Well, I know that I'm currently inside of my machine. If I go into Postgres, I'm entering through port 5432, which it doesn't show me there. Let me go ahead and quit real quick. Right, so we know that Postgres is living within port 5432. And we know that 5432 inside of Docker is also being utilized. So let me have this image here. So my machine has its own Postgres living at port 5432. But Docker also has Postgres living in port 5432. Right, this is the port within my machine. This is the port within Docker. Well, now how do I make this Docker port of 5432 talk to my machine? Well, what I'm going to do is I'm going to specify Docker to connect to my machine through a specific port, which in this case, just for simplicity's sake, I'm going to do 5433, so that my machine can talk to 5433 instead of 5432, so that I enter Docker and not Postgres within my local machine. So let's take a look at how that would look. Well, now, same thing. I'm going to run this image. I'm going to run it as a background service. But now I'm going to pass this new flag, which is -p. So I'm going to tell it that I want you to link these two ports together so that I can have access to the information within this container. So first argument will be the port within my own machine. And the second argument will be the port within Postgres. I mean, within Docker. So here we can see that I'm running it. Port 5433, that's my machine where it's going to be linking to Docker. And port 5432 is where Postgres is going to be talking to Docker. My Postgres instance within Docker is talking. Right? I'm not connecting to the one within my machine. I am connecting to the one within Postgres. Okay, so now that I have that information, same thing, I'm going to give it the -- remove flag. I'm going to give it a name, which in this case is just going to be Postgres. And then I'm going to specify that it's going to build this from my Postgres container. All right, so now it seems like it built correctly. I'm going to run docker ps to check the status. So here it gives me my ID. It gives me my Postgres container. It tells me the commands that were used, when was it created, what's its status. And then finally, it tells me the ports. Well, it tells me that port 5433 within my local machine, 0000, is connected to port 5432 within Docker. And then the name of this one container is named Postgres. Now, we went over all of that, but what does that mean? What is it that I can do now? Well, now I can run PSQL or pSQL to be able to enter this one Docker instance. But I need to tell it how to enter. So now all I'm going to do is I'm going to tell it, hey, you're going to enter through the host of localhost. So that's my computer. You're going to enter through my computer. And you're going to enter at the port 5432. 33. And what I want you to enter is I want you to enter to do DB. Because that is the same that I have here. All right, this is the database to do DB. So that's what I want you to enter. I want you to enter to do DB. Well, let's see what it does once I run this command. So it's going to ask me for the password for the user Francisco Avila. And that is my password. So that should be P3R5535. Okay, so it's trying to enter as Francisco, right? Or as Francisco Avila. And that's not the current user that I have. The current user that I have is Postgres. So maybe I need to change that real quick. I can probably specify the user and password arguments. Let's see how I can do that. Let's see, specify to PSQL username and password. Okay, so it looks like this is the correct command down here. It looks like I pass password in first, and then after that, it goes into it. So let's see. Let's do PG password. That should be equal to FR. Then I'm going to pass pSQL with the username of.
Spelled password wrong, Francisco.
Nice. Good catch, Dakota. Okay, so my user is going to be Francisco. And then everything else is going to remain the same, right? I want to enter the host, local host, the port 5432, or excuse me, 33. And I want to enter to do DB. And there you go. All right, so I was able to pass in the same password that I had within my Docker file. The same password was FR. Here's the password command, PG password FR. I was telling pSQL that it's going to enter as Francisco. There's Francisco. I was telling it that it's going to enter as localhost. And that's not showing it here, but we'll go over that. And a port 5432 for to do. And now we can see that we're within Postgres. Everything else works exactly the same. All right. I can run -L. We can see that there are no other databases other than to do. And we can see that all of them are created with the owner being Francisco. Now, this database is living within Docker, not my local machine. Okay, so finally I can exit. I can do -Q, and I was able to exit. And I can run Docker PS. We can see that that command that linked port 5433 worked effectively, because when I specify localhost at port 5433, I'm able to enter this Postgres instance or this Postgres container. All right, and that is how you get Postgres running on your machine locally. Once you have that running, everything else is just regular Postgres commands, right? We can still run create DB. We can copy from specific file if we need to. Everything is just Postgres commands after that. And that's going to conclude our lecture for the day as far as everything that we have to cover. So in summary, or actually before we even go into that, does anyone have any questions over anything that I've just covered so far? Pretty straightforward.
I have a question about, you mentioned earlier for group projects, this could come in handy. is it? When, I guess what I'm trying to ask is if we utilize this on the group project, would it more so be geared towards the database part, or would we like also maybe use React and stuff in this in Docker as well?
It's going to be for the whole thing. So it's by the end of this week. Yes, it should be this week. By the end of this week, you'll have your entire full stack application inside of containers. So we're going to go one step at a time. Today we're covering Postgres. Tomorrow we'll be covering Django and Postgres and how they connect to each other within their individual containers. And then Friday we'll be going over, because today is Wednesday, in fact, yes. And then Friday we'll be going over how to connect all three of them.
Okay, copy that. Thanks.
Of course. Any other questions? Okay, great. So in summary, today we went over what is Docker. We talked about the benefits of Docker and what it has to offer. We talked about how it runs within our local machine. We covered what is a file, an image, how to create a file, and how to utilize that file to create an image, and then utilize that image to run a container. We haven't talked about containers versus virtual machines just yet, I believe. So let's cover that conversation real quick. So for those of you using WSL, everything that we just did might have been pretty similar to what you have within WSL, right? WSL is an independent machine that's living inside of your local machine because it's a virtual machine. Well, that's the same thing when it comes to Docker. It's not running an entire virtual machine because a virtual machine comes with all the capabilities or the majority of the capabilities of a computer, while a container comes with the very minimum needed to be able to run the Docker instance that we're trying to create. So that's the main difference between the two. Virtual machines have all the functionality. Containers only have the necessary functionality to be able to run the specified directions. All right, we covered also how to create a Docker container from running PostgreSQL. And we also covered how to enter that container and map it to our local machine. Does anyone have any questions over anything that was taught throughout the duration of this lecture? Okay, if you have no questions for me, then I am more than confident in everyone's ability to be able to run a Dockerized container. Can you please put this stuff on Victor Nodes? Yes, it is all on Victor Nodes and it will all be pushed immediately after this recording. All right, fantastic. And then I'll try to copy down this image and put it on there as well. I'm going to go ahead and stop the recording now.